Auto healing. Kubernetes comes with features that can auto heal both your pods and nodes. Today's topic is on liveness and readiness proofs that can help your application to auto heal. This is Ryan Fish. You're watching. Consider this boring stamping company. As the name says, the job of this clerk is to stamp envelopes. First problem that the company faced was that the clerk can only stamp 5 envelopes at a time. Then he will stop accepting new envelopes. Supervisor will inform the boss. To get more envelopes stamped, company employed 2 additional clerks to do the same job. Boss will pass new envelopes to the clerk who is not busy. There is one more problem. Randomly, these clerks fall asleep at work. Funny, but yes, the supervisor has no choice but to pour water to wake them up. And then the work continues. That's an easy one to follow, I guess. Now, how does this map to our Kubernetes cluster and Kubernetes concepts? The boss represents the service in Kubernetes. Supervisor represents kubelet, a component of Kubernetes. The clerks or the employees represents the pods. Actual topic of our day was about liveliness and readiness check, right? So, readiness check is the one that validates your pod, specifically container, to see whether that is still available for accepting request or not. In our case, when an employee is busy processing more than 5 envelopes, he stops accepting any new envelopes. So at this point of time, readiness probe will have a notion that this particular container or the pod cannot accept new orders and it will stop directing traffic to it. The second scenario is the liveliness probe, where due to some reason the pod is not responding anymore. In our case, the clerk starts sleeping in his desk. In this case, liveliness probe knows this. Kubelets go ahead and restarts that container. Of course, in our case, we are pouring water to the employee so that he can resume work. All this happens seamlessly in Kubernetes. That way, even if some pods are not responding, even if some pods are really busy, your whole traffic and application will still be available, and then the whole things get auto healed. Now let's jump into demo. Before we move on, if you are already liking this video, don't forget to subscribe and give a thumbs up. To explain our analogy better, I created this deployment. As you can see, the name is clerk. For now, I am just creating one clerk. We'll increase the replicas a little later. And then for now, the labels are role clerk. So the container I'm going to use is BusyBox. BusyBox is a lightweight Linux container. I am passing a very simple argument, lots of commands, but simple argument for the shell. The first one is httpd-p80. I am asking BusyBox to start a HTTP server, Apache server in the background, and then I am creating a folder called I am awake, and then I am creating another folder called I am free. I am asking the BusyBox to sleep for 60 seconds, and then it will remove this folder I am free. It means BusyBox tells that it's busy. This is matching with our analogy where after some time our clerk is getting busy and he won't accept any new envelopes. The next thing is I am waiting for 90 seconds and then I'm removing I'm awake. This to explain the scenario where the clerk sleeps off. Okay, it might look little complicated, but just to repeat it, I'm starting a Apache server that's listening in port 80 so that we can create a service pointing to this port. I'm creating two folders, I'm awake and I'm free, and then I'm deleting them after a few seconds. Now let's see how the liveliness probe works. As you see in the liveliness probe, I've mentioned to check for this folder, I'm awake. What does it mean? It means the kubelet keeps checking whether the I'm awake folder is available or not. Once it is not available, it will go ahead and restart that container. Just like our supervisor pour water on the employee who is sleeping. So these are interesting attributes of liveliness probe. The first one is initial delay seconds. Sometimes our container might take some time to boot up. So rather than immediately checking whether a liveliness is okay or not, we can use this initial delay in seconds to wait for first 5 seconds and then start analyzing the liveliness probe, meaning start checking this command. Period seconds is how frequently this should be run. So the same check will be run every 5 seconds. Timeout second is in case our command is going to timeout, how long it should wait. So I've mentioned 1 second. Some of these has default values. I just added these attributes here so that I can discuss about every attribute that is there. The next one is success threshold. If this command succeeds at least for once, then we will mark the container as healthy. So next one is failure threshold. Value 3 indicates if it fails continuously for 3 times, then we will mark the container as unhealthy, which means kubelet will go ahead and restart the container. I hope this is clear. So liveliness is keep on checking whether the container is awake or not. If it goes to sleeping, then it immediately restarts it. Readiness checks whether the container is free or not. So basically it checks for this folder whether the folder is available or not, which we delete after some time, which is mapping to our analogy when the clerk is getting busy processing more envelopes. Again, here all those attributes are applicable, but for now we are only using initial delay seconds and period seconds here. I hope that is clear. So that's our deployment. And then I created a service. So that's our boss who is actually allocating the envelopes to the clerks. And then I'm pointing it to port 80. So for this service to come up and running, we need something to be listening in port 80. So that is the reason why we actually put this command to run an Apache server in the background on port 80. Let's try creating this one. So our usual command, kubectl apply -f. So it's creating the deployment and then created the service as well. If you see, it has created one clerk. Of course, our service is also created. Just to show this visually, I'll switch on to another application called Octant. It gives a very nice visualization of the whole thing. This is very similar to Kubernetes dashboard, but it has some additional visualization. So I thought it will be interesting to have a look. In Octant, if you look at the services, we can see the boss service has been created. And there is a target endpoint also created. I'll explain about the target endpoint shortly. So as you see, the boss is actually passing the envelope to the clerk. There is only one clerk working right now. He might get busy or he might fall asleep very soon. So let's increase the replica. If you come back here, look at the pods. There are 3 pods. Of course, the other 2 pods are getting started right now. Yeah, all of them are active right now. Let's look at the endpoint. But we are seeing only 2 endpoints. It means there is some pod that is not working well. So as you can see here, the first pod that we created a few seconds back is not in ready state anymore. which means he is already busy processing more envelopes and he stopped accepting any new connections. So he is not ready. So the service will pass the traffic to the remaining two pods. What does it mean? So every service creates a resource called endpoints. So our service, the boss, created an endpoint and currently it is only redirecting it to two pods. So every service creates an endpoint. These endpoints actually point to the pods through which the traffic should pass. So in our case, the first clerk is already busy, so he is not processing any new request. So we are only passing the traffic to the remaining two pods. This is automatically taken care by service. Whenever some pod is not ready, it will redirect the traffic to the remaining pods. As you can see now, there is no more endpoints left because everybody is busy, or in other words, our script has run and deleted I am free folder. If you look at the pods, none of them are ready, and so it's obvious there is no endpoint, there is no traffic that can pass because everybody is busy. Hope that clarifies. If we wait for a few more minutes, we'll see the pods are getting restarted. As you see already, this particular pod got restarted and it started accepting traffic. So what does it restart? The restart happens because our liveliness probe failed. As you can see, the liveliness probe has failed. This is the reason why Kubelet restarted the pod. And so we can see it has been restarted once. And now it's again ready for accepting new traffic. Let's look at the endpoints. Now, the traffic is getting passed to this clerk who is available and he is processing the particular envelopes. Both liveliness and readiness probes supports different kinds of probes. The one that we are using here is based on command, as we are using the cat command, but we can also use HTTP and TCP checks. Those are again very straightforward. You validate a particular port or you can validate a particular response and then accordingly you can react. I hope that clarifies the concept of liveliness and readiness probes. If you still have any questions, please feel free to put it in the comments.